Okay, so permutations. It's an arrangement of objects where order matters. A factorial is the exclamation point, and that's going to be the product of all integers from n, the number given to you, down to 1. So 6 factorial just means 6 times 5 times 4 times 3 times 2 times 1. And on the calculator, you can definitely multiply all of that out. So we've got 6 times 5 times 4 times 3 times 2 times 1, and the answer comes out to be 720. What's nice about factorials is you can also actually use a factorial notation, which is also found on your calculator. So if you can follow along with this, another way to do 6 factorial is as follows. You type in the number 6. You type in the math. You arrow over to probability. Down to choice 4, you hit enter, and then you hit enter again. Same exact answer. So what I will do is put up a blank page real fast for factorial on calculator. You're going to type in number. You're going to type in math. You're going to type in or arrow over to probability. You're going to go down to choice 4, and then I believe that you hit enter twice. Enter, enter. Okay, so feel free to use that for factorials. If we then go to this next example, let me back up for 1 second. Okay. Example 1. Suppose Sandra, Lisa, and Patty go to a movie. How many different ways can the girls line up to buy their tickets, and list the outcomes? Well, there's 3 girls. And the 3 girls means that I can have all 3 girls whose order matters as a 3 factorial. Or I could say it's 3 times 2 times 1, or do on the calculator. Either way, it's 6 outcomes. And these are the 6. We could have Sandra first, followed by Lisa, then Patty, or Sandra followed by Patty and Lisa. Lisa could go first, followed by Sandra and Patty, or Lisa could go first, followed by Patty and Sandra. Finally, Patty gets her chance being first, followed by Sandra and Lisa, or Patty, Lisa, and Sandra. So when you're dealing with a certain amount of things and you're using all of those things, for example, lining 3 girls up in line, then you've got a 3 factorial, which means all 3 people are being used, 3 times 2 times 1. This we did already. Consider the number of permutations of the letters in the word July. And how many ways can you arrange all of the letters? Well, if I'm going to use all 4 letters, I've got that 4 factorial, which is 4 times 3 times 2 times 1, and that comes out to be 24 ways. Well, if we change this permutation and we only want 2 of those 4 letters, then what we need to do is just deal with the first 2 sets of choices. It's not a factorial. It says, well, I've got 4 choices. Let me put this down here. So I've got choices. I've got 4 choices of letters for my first letter. And then if I use a letter, there's 3 choices left. I only want 2 letters in my word. So then I've got 4 times 3 for 12 ways. Okay, so a factorial works when it's with all the letters, and a factorial doesn't work quite the way you would think so if you have just some of the letters. Here are some permutation formulas. The number of permutations of n objects when all n objects are used. If we're having n objects and all n objects are used, we've got the factorial that we know, but you could also do what's called an NPN. So if we think about, again, the letters of the word July, and we want to use all 4 letters, it's a permutation, the order matters. There are 4 letters to use, and we use all 4. On the calculator, what you're going to do is this. You're going to go and you're going to type in the number 4. You're going to go back to math. You're going to go over to probability. You're going to go down to choice 2, which you'll see that it says something like, I believe it says NPR. And then you're going to do the 4 letters being used, and then I believe it's enter twice. Let's see if we can test that out. Okay, so here's my calculator, and I'm doing the 4P4, right? So I've got 4. I'm going to math. I'm going to probability. Choice 2, NPR. I'm going to hit enter. I want all 4 letters used, so 4 letters given and 4 letters used, and there's my answer of 24. If you're not using all of the letters, and you're having n objects taken an R at a time, then you only want this formula right here. I'm actually going to have you guys cross this out. I'm not going to be worried about that right now. So if we are using those same 4 letters, and we only want to use 2, then what we're doing is, it's still a permutation where I've got 4 letters to choose from, but only 2 are actually being used. And then again, if I go back to the calculator, we know the answer already was 12, but I could show you 4, math, probability, whoopsie, get back up there, probability, choice 2, and I only want to take 2 of the letters, and there's your answer. Okay, so that's a shortcut. Example 3, suppose your band has written 10 CDs, or 10 songs, excuse me, and plans to record 4 of them for a demo. In how many ways can you arrange the songs on the CD? Well, it's a permutation. The order matters. A song comes first or a song comes last. Either way, there's 10 songs, and you're only choosing 4 of them on your CD. You can go to the calculator, or you can realize that I have just 4 numbers to use. I start with 10 choices. I choose 1. I'm down to 9. I choose another one. I'm down to 8. I choose my last song, 4 songs only, and I'm down to 7. However you choose to do this on the calculator, the answer comes out to be the same. 10, math, probability, choice 2, enter, 10 songs to choose from, all I want are 4, 5,040. Same answer as 10 songs to choose from, then 9 songs left, then 8 songs left, then 7 songs left. It's still 5,040. So this answer becomes 5,040. All right, let's keep on going here. This is supposed to say the word family. It doesn't. It just has 5 letters, so I apologize about that. So using the letters of the word F-A-M-L-Y. It's a typo, no big deal, but let's just use what's given here. So it's 5 letters. Find the number of ways you can arrange all the letters of the word. Well, if there is a permutation, 5 letters given, 5 letters used, again, realizing that's the same as a 5 factorial, which is the same as 5 times 4 times 3 times 2 times, whoopsie, times 1. You can go onto your calculator, put in whatever you want. I'll do the factorial choice on this one. So I'm going to go 5, math. I'm going to back into my probability this time. Go down to 4, hit enter, and hit enter again. There's 120 combinations. So then we've got 120. If we only use 3 of those letters, it's a permutation. 5 letters are given to you. You're only choosing 3. If you want to show it by hand, it's 5 times 4 times 3. Not even going on the calculator. 5 times 4 is 20. 20 times 3 is 60. Okay. Suppose you're asked to find the number of permutations when not all of the things are different. So for example, find the number of permutations of the letters of Mississippi. But you've got to be really careful because they're duplicate letters. Just make sure that you notice there happen to be 4 letter I's, 4 letter S's, and 2 letter P's. So what happens this way is we're going to follow this sort of formula where there's a factorial of how many letters are given divided by a factorial of all the duplicates. So what that means is you're going to have 11 letters in Mississippi. Grab some water. Sorry. So you're going to have 11 letters in Mississippi, 11 factorial, and that fact that there are 4 I's, 4 S's, and 2 P's. On the calculator, just make sure you put parentheses around your denominator so you get the right answer. Here's how it's going to work. Figure this out. 11 factorial, sorry, divided by, in parentheses, 4 factorial, another 4 factorial, and a 2 factorial. Close up your parentheses, and there are 34,650 ways. Okay? Last 2 problems about this. Find the permutations of the letters of the following for bubble. There are 1, 2, 3, 4, 5, 6 letters in the word bubble. So there's 6 letters. But there are 3 B's. Oopsie, there are 3 B's. So the setup would be, okay, I've got 6 factorial divided by 3 factorial, just the repeating B's. And then here, my answer then just comes out. 6 factorial divided by 3 factorial. And there we get 120. Color green, I think I'm on. Last problem before you get to the homework. So last one is this. Jill, 8 quarters, 5 dimes, 3 nickels, and a penny. The coins of each denomination are indistinguishable. How many ways can she place the coins in a straight line? Well, how many coins exist? 8 quarters, 5 dimes, that's 13, plus 3 more nickels, that makes 16, plus 1 more makes 17. There are 17 coins. So you must start off with the 17 factorial. We're dividing it by all the duplicates. The duplicates would be, well, 8 of them are quarters, 5 of them are dimes, and 3 of them are nickels. All you need to do on your calculator is just finish this thing up. So I've got 17 factorial, 17 math, probability, choice 4, divided by parentheses, 8 math, probability, factorial, 5 math, probability, factorial, 3 math, probability, factorial. Close up your parentheses, and in terms of the coins, lots of ways to do this. 12,252,240. Perfect. Okay, so you guys should be good to go then. So permutations, the order matters. You can use some of the formulas. You can do stuff by hand. Whatever you choose to do is fine with me. I will see you guys in the morning. Bye.